So now we'll be looking at the rules of differentiation. So what are the rules that will apply when we want to solve some differentiation questions that we cannot just solve with the general formula that we've looked at? So the first rule we'll be talking about is the chain rule, and I will explain this concept with an example. So here we are told to differentiate this function y is equals to 2x plus 3 the all squared. So now I can see that I cannot apply the formula directly because what I have here is not x. So what do I do? So what I can do now is I can try to express what is inside this square bracket as another variable. So I can say let u be equals to 2x plus 3, and once I do that I can substitute that into this expression here. So that becomes y is equals to what? U squared. So now I can easily differentiate this expression with respect to u. So now I can say I can find dy over du. So now this is the same thing as finding dy dx, just that instead of having x I have u now. So now what would dy over du become? Then this 2 comes down, so it becomes what? 2u, as we've discussed before. So now this expression over here, I can find du over dx. That means I should differentiate this expression with respect to x. And when I do that, what does this become? 2x, since this becomes the coefficient only, so 2, and this 3 gets terminated because it's a constant. So now what happens when I multiply dy over du by du over dx? As you can see, du cancels out du and I'm left with what? Dy over dx. So dy over dx is the same thing as saying dy over du, which is 2u times du over dx, and du over dx is 2. So what does that give me? That gives me what? 4u. Now I can replace back the value of u, so 4 into bracket, and my u value is what? 2x plus 3. So when I differentiate this function, I get my dy over dx to be equals to 4 into bracket 2x plus 3. So in general, the chain rule tells us that if I'm trying to find dy over dx, that is also equals to finding dy over du first and multiplying that by du over dx. So let's look at some further examples to explain this point. So in this first example, we are told to find dy dx in these functions, and to do that we are told that y is equals to 3x squared minus 2 then all raised to power 3. So again, like we did before, we are going to make everything inside the bracket sign to be equals to u. So I'll say let u be equals to 3x squared minus 2. So now I know that I can find du over dx. So my du over dx will just be the differentiation of this, and this become, when I bring this 2 down, I have 3 times 2 and I have 6. Then this become x, then 2 minus 1 is 1. When I differentiate 2, I get 0. So this is du over dx. So now I can write out my y now as I've said let this be equals to u. So I can replace what is here by u cube. So I can find dy over du. So when I differentiate y with respect to u now, this comes down, so I have 3u, then 3 minus 1 becomes 2. I have 3u squared. So as we explained, from our chain rule, we know that dy over dx is equals to dy over du times what? Du over dx. So what is my dy over du? Found out to be 3u squared, and my du over dx is what? 6x. So that becomes what? That becomes 18x times u squared. So now I can substitute back the value of u. So now that becomes 16x, and my u, we made it to be equals to what? You know that it was 3x squared minus 2. Then since I'm finding u squared, I just square this also. Pretty straightforward. So now let's look at this example over here. So in the same idea, I can replace what is inside this square bracket, inside this bracket, by u. So I'll say let u be equals to 6 minus x squared. So I can find du over dx. So du over dx, a constant will be 0, and minus x squared will give me what? Minus 2x when I differentiate it. So now I can replace this with u. So I have my y is equals to 5 over, then this becomes u cube. So this becomes 5u raised per minus 3 based on our law of indices. So I can find dy over du. So dy over du becomes, I have minus 3 times 5, which gives me minus 15 times u raised per minus 3 minus 1, which gives me minus 4. Which is same thing as saying minus 15 over u raised to the power 4. So now I know that my dy over dx will just be multiplication of dy over du by du over dx, which is minus 15 over u raised to the power 4 times minus 2x. Minus 2x times minus 15 gives me what? That will be 30x over u raised to the power 4. Now I know what my value of u is. My u is 6 minus x squared. So I can replace it back. So I have my dy over dx to be equals to 30x over, then my u is 6 minus x squared, then everything will raise to power 4. So now let's look at 2 more examples to explain the chain rule. And these examples have to do with the trigonometry functions. So the first one, we're told that y is equals to sine 5x. But if you look at this example, we cannot just make this equals to, we know that sine x, when we differentiate it based on what I asked you to memorize, will give me cos x. But this is 5x. How do I deal with this? So the same idea, I make this be equals to one variable. I say let u be equals to 5x. So I have du over dx. When I differentiate that, I get 5. So now my y value will be equals to what? Sine u. And my dy over du will be equals to, when I differentiate sine u with respect to u, I get what? Cos u. So my dy over dx will just be multiplication of those two terms, which will be equals to what? Cos u times 5, or 5 cos u. So my dy over dx will be equals to 5 times cos, and my u value is what? 5x. So I have 5 cos 5x. And finally, here we're told to differentiate y is equals to 7 cos 7x with respect to x. And in this example also, we have what? 7x. So how do we deal with this? So the way we deal with this is that we say let u be equals to 7x. So I have y equals to what? 7 cos u. So now I can find du over dx. When I differentiate 7x, I get 7. And when I differentiate y with respect to u, dy over du becomes, differentiation of cos u gives me minus sine u. That becomes minus 7 sine u. So my dy over dx will be equals to 7 times minus 7 sine u. And that is equals to what? Minus 49 sine u. And I can replace the value of u, which is 7x. So dy over dx equals to minus 49 sine 7x. So now this is how we deal with the chain rule, but there is a shortcut towards solving it, and I'm going to walk through the examples explaining the shortcut again. So let's go through the previous examples that we've worked on. And in this example that I've first solved, another way to think about solving this kind of thing, or when you see something like this, is the first thing you have to do is you try to differentiate what is inside the bracket. And if you look at this expression, when you differentiate what is inside this bracket, 3x squared becomes what? 6x. And then you now try to differentiate everything as if this was a single term. And when you do that, you have what? Times 3 raised to power 3x squared minus 2. Then 3 minus 1 becomes 2. So 6 times 3 gives me 18x into bracket 3x squared minus 2 squared. As you can see, this answer is equals to this answer that we got. So they are basically the same thing, but this just involves doing more of the procedures in your head. And you really need to practice so you can be that fast, because time is of the essence when you're talking about solving JAMB questions. So to apply that same concept here, to solve y is equals to sine 5x, the way you go about this is to try to differentiate what is here. Now when I differentiate 5x, I know I'm going to have 5, and now I'll just imagine that this is a single variable here. And when I differentiate sine x, I know I'm going to get cos x, so this becomes cos 5x. So I'm left with what? 5 cos 5x, which is the same thing as what we got before. But again, I would suggest that you solve it with the normal steps that we have done before, and by the time you practice with lots of questions, then you'll be able to tackle it more quickly. So now let's look at another law of differentiation, and we're going to be looking at the product rule. So what is the product rule all about? So if you have the product of two functions u and b, we can differentiate it or find the difference derivative by applying this formula. And this formula tells us that if you have function u and v, that the differential is given as, or derivative is given as u dv over dx plus v dv over dx. So the best way to illustrate this is to use an example. So now we have two terms here, this term here and this term here. So what we do is that we name one of the term u and we call the other v. So now to get started, we've said u, so based on our formula, we need to find u, we need dv over dx, we need v, and we need dv over dx. So let's start out with u. So u is equals to 3 plus 2x. So what will be du over dx? Du over dx will just be the differentiation of this. Differentiation of 3 is a constant, which will give me 0, and differentiation of 2x will give me 2. So I have my du over dx to be equals to 2. Now what about our v? Our v we said to be equals to 1 minus x. So what will be my dv over dx? So when I differentiate 1, I get 0. When I differentiate minus x, the coefficient here is minus 1, so this becomes minus 1. So now I found the values of u du dx, v dv dx. So I can apply the formula now. So now the differential dy over dx now will be equals to u based on the formula, which is what? 3 plus 2x times dv over dx. dv over dx we found to be minus 1. Then plus v, which is 1 minus x, times du over dx, which we found to be 2. And when we expand, this becomes minus 3 minus 2x. This becomes plus 2, and this becomes minus 2x. And when you simplify that, it results in minus 1, then minus 4x. So when you differentiate this expression, this is what you get. So to recap, when you have two functions or you have two terms, in terms of a product, what you do is you make use of the product rule given by this formula, and you have to memorize this formula also. So you take the first term and you multiply it by the derivative of the second term plus you take the second term and you multiply it by the derivative of the first term, which is what we did here, and we simplified it to get this. So let's look at some more examples. So here we are told to differentiate y is equals to x squared sin x. So here also we can see that we have two product of x squared and sin x. So our sign one to be u and the other to be v. So I will say u is equals to x squared. So my du over dx will equals to what? 2x. Now my v is equals to sin x, and based on our trigonometric ratio, dv over dx will be equals to what? Cos x. So I can substitute it into the formula. So my dy over dx now will be equals to my u, which is x squared, times dv dx, which is cos x, then plus my v, which is sin x, times du dx, which is 2x. So when I differentiate this, I have what? X squared cos x, then plus 2x sin x. So if you see this carefully, what have we done, or what does this represent? We took the first term, which is x squared, and we multiplied it by the derivative of the second term, which gave us cos x, plus we took the second term sin x and multiplied by derivative of the first term x squared, which gave us 2x. So now we're going to apply that concept to find this directly. So I'll just solve this directly. So I can easily write that dy over dx will be equals to, this is the first term and the second term. So according to the law, I'll take the first term, which is 3x, then I multiply by the derivative of the second term. The derivative of tan x, my trigonometric ratio, is what? Is sec squared x. Then plus, I take the second term, which is tan x, and I multiply by the derivative of the first term. When I differentiate 3x, I get 3. So dy over dx will be equals to what? 3x sec squared x plus 3 tan x. So as you can know, these are two different terms, and this x goes with this tan. That is why I can multiply 3 and x goes with the 10, so the 3 has to come before it. So this is just a simple application of the product rule. So now let's look at even one more example of applying the product rule. And to apply the product rule here, I'm going to go through the long method. So we call here again, we label here as u, and we label this guy over here as v. So we start out, so we say u is equals to what? X squared plus 3. So now I can find du over dx, and du over dx is just going to be 2x, because 2 come down, then 2 minus 1 is 1, so 2x, and 3 becomes 0. Now for my v term, I have v to be equals to cos 3x. But now how do I find dv over dx? So to find dv over dx, you remember that I have to make use of the chain rule, because what I have here is x, is 3x, and not just only x. So to do that, so when you solve this, normally what you do is that you differentiate this term here. So when I differentiate 3x, I have 3, and you multiply it by the differential of this. When I differentiate cos x, I have minus sin x, so this becomes minus sin 3x, and that becomes what? Minus 3 sin 3x. So if you have not gotten the hang of this, I'm going to try to solve this out using the chain rule explicitly. So to do that, we have v is equals to cos 3x. So I can say let u be equals to what? 3x, or I've already used here, so let me use a new variable. I can say let a equals to 3x. So this becomes what? V is equals to cos a. So now my dA over dx equals to what? Equals to 3. This is pretty straightforward. And in this case, my dv over dA will be equals to what? Minus sine A. Now, if you recall, for my chain rule, dv over dx equals to what? Dv over dA times dA over dx, because this cancels out to give me dv over dx. So that becomes what? Minus sine A times 3. That becomes minus 3 sine A. And A, we told that it was 3x. So that becomes minus 3 sine 3x. So as you can see, we got what we got. Yeah. So now that we have gotten these terms, we can now apply our product rule. So to apply our product rule, we take, so dy over dx now will be equals to, I take the first term, which is x squared plus 3, then I multiply it by the derivative of the second term, which I found to be minus 3 sine 3x. So I have minus 3 sine 3x, then plus, I take the second term, which is cos 3x, and I multiply by the derivative of the first term, du dx, which I found to be 2x. So when you simplify this, you have your dy over dx to be equals to minus 3 times x squared plus 3, then times sine 3x, then plus comes 2x cos 3x. So this is the differential of this function over here, and this explains how we make use of the product rule. So now let's go to another rule that I'll be looking at, and the final rule for the purposes of JAMB, which is the quotient rule. So the quotient rule has to do with division. As we saw, the product rule dealt with multiplication, while the division rule now the quotient rule deals with division. So if we have a function f is equals to u over v, and we want to find dy dx, the same thing as having v, the denominator, multiplied by the derivative of the numerator, du dx, then minus the numerator, which is u, times the derivative of the denominator, which is dv over dx, then everything will be all over the denominator squared over v squared. So let's see how to apply that. So the first thing we do is we label the numerator and denominator. So we call here u and we call here v. So we can write out that u is equals to 1 plus x squared. So I can easily find the value of what? Du over dx. Differentiation of the constant gives me 0. When I differentiate x squared, I have what? 2x. Now for the denominator, I have v is equals to 1 minus x squared. So the dv over dx, when I differentiate a constant 1, I get 0. When I differentiate minus x squared, I get what? Minus 2x. So now I can substitute all these values into the formula. So dy over dx is equals to v, which is the denominator, and v in this case is what? 1 minus x squared, times du over dx, which I found to be what? 2x, then minus u, which is 1 plus x squared, then times dv over dx, which I found to be minus 2x, then everything is now all over the denominator, v, which is 1 minus x squared, then everything I'm going to what? Square it based on the formula. So when I simplify this, 2x times 1 gives me 2x. 2x times minus x squared gives me minus 2x cubed. Then 2x minus 2x times minus give me plus 2x. Then plus 2x times x here give me plus 2x. And plus 2x times this gives me plus 2x cubed. Then I have over 1 minus x squared all squared. So this term cancels out this term. 2x plus 2x gives me 4x. So this is same as having 4x over 1 minus x squared all squared. So pretty straightforward. So to recap, when you have division of two functions and I want to differentiate it, what you do is that you take the denominator, which is v in this case, and you multiply by the derivative of the numerator minus, you take the numerator, multiply by the derivative of the denominator, then divide everything by the square of the denominator. So let's take a look at these two last examples on that quotient rule. So here now we're told to find dy dx, and as you can see we have the division of two functions. So what do? I call one of it u, I call the numerator u, and I call the denominator v. So if u is equals to cos 3x, that I need to find du over dx. So du over dx, so now I would suggest that you take your biro and pencil and you try to solve it out using the chain rule. And if you did that correctly, you have to get minus 3 sine 3x. So what I did was that I differentiated this to get 3. When I differentiate cos 3x, I got minus sine 3x. But if you don't understand this, you can solve it out the full way, and I'll encourage you to even do that. So now I take the denominator v, which is x squared. So when I differentiate the v over dx, what do I have? I just have 2x. So now applying the quotient rule, we can find dy over dx. So dy over dx will be equals to, now we have the denominator, which is v in this case, x squared times derivative of the numerator, which is minus 3 sine 3x, then minus the numerator, which is cos 3x, multiplied by the derivative of the denominator, which is what, 2x, then everything will be all over the denominator squared, in this case x squared all squared. So dy over dx becomes what? This becomes minus 3x squared sine 3x, then minus 2x cos 3x over, and this becomes 2 times 2x raised to the power of 4. So when you differentiate this function using the quotient rule, this is what you get. So now let's look at another example, which will be the final example here. So the same way, I label the numerator as u and I label the denominator as v. So I can write out that u is equals to 2 plus x. So I know that my du over dx will be equals to, function of a constant is 0 and function of x will give me 1. I know that my v is x squared plus 2x plus 7. And my dv over dx will just be the differentiation. So the function of x squared will give me 2x, function of 2x will give me 2, and function of 7 will give me 0. So now I can apply the quotient rule. So it says dy over dx will be equals to v, in this case my v, which is denominator, will be what? X squared plus 2x plus 7 times the derivative of the numerator, in this case it should be 1, then minus the numerator should be 2 plus x times the derivative of the denominator, which is what? 2x plus 2, then everything will be all over the denominator squared, or v squared, in this case which will be x squared plus 2x plus 7 squared. So I'm going to stop here, and you can try to simplify this further on your own. So now, by now, I believe that I've gotten the main idea behind the chain rule, the product rule, and the quotient rule. So now, knowing how to apply this doesn't just come easily. You can only attain mastery by solving questions. So I advise you to go through your textbook now and try to look for questions that are relating to chain rule, product rule, and quotient rule, and try to solve as many as you can. And once you begin to do it, begin to get faster at solving them and get to a point that you can just write it out in just a single line. So when you've gotten that level, then you know that you are really prepared to take on JAMB questions promptly. So in the next module, we are going to be looking at higher derivatives, and that will round up our discussion on differentiation. So bye for now.